Hi everyone, how are you doing? I hope everyone doing well. Welcome to AM2002 Numerical Analysis. So my name is Dilu. I will be the coordinator of this course. So I will give you a brief introduction about this course. So before that, let me put it in this way. So traditionally, engineering and science had a two-sided approach to understand a subject. So theoretical framework and experimental framework. So with the development of computers, we have another dimension, which is computational framework, right? For instance, you can use computers to predict weather patterns, to compute the trajectory of a spacecraft, to calculate values of stocks, to decide air ticket price, and so on. Right? So now we know that computers help us in many ways. So let's talk about numerical method. So what are numerical methods? So we would say there are algorithms uh, that would compute approximations to things you want to find. For instance, you want to differentiate a complicated function or integrate a complicated one, or you want to find solutions to a function that is difficult to find analytical solutions. So in this case, if you encounter these cases, you will go with numerical methods to find some approximate solutions, right? To find approximate solutions, we can implement an algorithm. That means you can write a program on a computer. So for that you need a computer, right? But in this course we learn some concepts about theorems. So we try to use those things, but in this course we don't do practical computer practicals. We just learn those theories, numerical methods, how to apply how to compute, how to differentiate functions using some kind of numerical techniques, those kind of things. So if you look at this picture here, so this is kind of overview to show how we are going to learn this little piece, right? So in this course, numerical analysis. So how does it fit into a bigger picture for scientific research? So suppose we have a real problem or physical model, right? We are going to study. For instance, could be measuring temperature of a system or car body, right? After understanding the principles that guide the model, then you will derive a mathematical model. So here you build a mathematical model for this problem. This is a real world problem. So first you have to study the problem. So you have to study the problem precisely. Then you can understand these are the significant parameters, so we have to include those parameters into this mathematical model. So we can ignore these parameters because that do not depend on the problem, right? So you can ignore those parameters, so we don't use those parameters to model the problem, right? So like that, you have to understand problem properly to develop a mathematical model. So very often this could be some equations or maybe differential equations that describe the physical phenomena, right? Of course, some problems you can solve exact, right? But most of them you cannot find solution exactly, right? So what what does it mean? So you find solution exactly, that means you would find analytical solutions to this mathematical model, right? So otherwise, if it is hard enough to find exact solution, or you cannot find, it is impossible to find analytical solution, then we go to numerical methods, right? We go with numerical methods. So here we are not finding exact solutions by using numerical methods. We find an approximate solution to this mathematical model by using numerical techniques, right? So for that, you need to go to a computer and write a program using a mathematical packages such as MATLAB, Mathematica, Maple, and so on, right? So this is this one. So first you have to implement an algorithm, then you write a program by using a computer, by using a mathematical software, right? You code that algorithm, right? You are coding that. So this is called computer programming part. This one is called computer programming part, right? So hopefully the program or code runs in the computer without getting any bugs or errors, so that you can get results, successful results. So using these results, these data, so you want to interpret that data, you want to see what happens in the solution, right? So you want to see that, right? So you can visualize your solution by plotting a graph, or by plotting a graph like that, right? You can visualize your solution, numerical solution, approximate solution, by plotting a graph. So at this stage, so we don't know this solution is correct or not. So you have to validate your solution, you have to compare your solution with this problem, right? So how do you compare with this real problem? So you can do experiments. So here this is the computer simulation part. So computer, so when you build develop a mathematical model, then you can implement an algorithm, then you can write a code for that algorithm, then using a mathematical software such as Mathematica, MATLAB, Octave, and so on. You can compute that, then and finally you get the results. Right now you have to validate this result whether this one is tally with the real problem or not. Right, you have to validate that. So how to do that? So you can do experiments you can do experiments, then you come up with some kind of values. Now you plug those parameters into your mathematical model, then you see your results, whether these results tally with or approximately equal to these outputs, these experimental data, right? So let's say these results do not agree with the real experimental data. So then I think you forgot to add some important parameter. You have to include some kind of parameters into your mathematical model. So that's why you are getting some weird solutions here. So you can consider this one again, mathematical model. So you adjust your model again, then again implement an algorithm and write a code for that and run on a computer, then you get the results. And again you can check these results with the real experimental data if until you get satisfactory results. That means that results agree with experimental data, right? You can iterate this one like this. You can iterate all the time. You have to check your results, output results coming from computer, from the model, with the experimental data, right? So you have to iterate. If not, you have to iterate this process again. Check this one, iterate this one, check this one, until you get satisfactory results, right? So this is the bigger picture of this course, numerical analysis. All the time. So if you are given a real problem, so first you have to study the problem properly to build a mathematical model. It includes, this is a complicated function or system of differential equations, right? So you build a mathematical model for the real problem, then you implement an algorithm for that, then using any kind of software, MATLAB or Mathematica, you can compute that on a computer. With help of computer, and you get some results. We don't know whether these are numerical, these are approximate, these are not exact solution to that, right? These are approximate solutions, right? So this is the procedure. So all the time we are dealing with numbers, right? Here I want to stress that numerical numerical methods are not about numbers, right? So they are about mathematical ideas and insights. Keep that in mind, right? So in this course, so yeah, so you had, yeah, so keep that in mind, in mind. So try to understand those concepts, ideas, and use those ideas to find approximate, all the time approximate solution to a complicated problem. So numerical. So I think so here, so we don't find analytical solution in this course. So all the time we find approximate solution. So I don't know. So you have to measure errors, right? So you have to find errors. We don't know errors, right? You have to evaluate, find errors to see whether your method is correct or not. So then, so if there's an error, and then you have to look at your mathematical model as well as your algorithm and computer program, right? Because of that, you are getting errors. So these results do not agree with experimental data, right? Have to check all of that. So I hope you understood what numerical method is, right? So in my next video I will right, let's see the subject content. So this is the content. In first week I think you will learn sequencer series and the order of convergence and how fast that series and sequence converges to that to its limit, right? We'll learn big O, little o, and some error analysis. All the time you are getting errors, so you have to measure those errors using, that is called, yeah, error analysis. You have to analyze those errors, so you have to minimize propagation error, right? All the time, so propagate errors because of many things. So you learn those things. So under section 2, so you will find solutions to nonlinear equations using bisection method and Newton's method. There are many methods, many numerical schemes. Second method, fixed point function iteration, like that. Under section 3, we will discuss interpolation. So if you are given a finite number of data set, so how to find a function going through those data sets, that kind of thing. You will interpolate a polynomial. That polynomial goes through those data point, right? Data points. You will learn, yeah, these things, spline interpolation, cubic splines. Here under section 4, we will talk about numerical differentiation, right? So if you are given a complicated function, so how to find the derivative of that some function? It's very difficult to it is very difficult to find the derivative. So we use several methods to find numerical differentiation, and under section 5 we will discuss numerical integration. So how to integrate a complex function. So and here you will learn your Simpsons rule, trapezoid rule, and quadrature formula, many things, many methods, numerical methods. These are methods. Yeah, many methods. Yeah, Gaussian quadrature, and so on. All right. I hope you understood something, so you got an idea about numerical methods and why we are using numerical methods, uh, and why don't we find analytical solution all the time. So sometimes you cannot, it is impossible to find analytical solution, then we go with numerical methods to find approximate solutions. That's why we use numerical schemes, different algorithm schemes. So you have to learn those schemes to find approximate solutions. Hope you understood this, and I hope you have a better picture about numerical analysis in second semester. Yeah, this one. So that's all for today. Let's meet next week.